Very good morning to all. I, Professor Yagnesh Gamba, welcome you. FDP on Automobile Engineering Past, Present and Future. Sponsored by AICT IST, organized by Automobile Engineering Department. Today we having the day 4, session 1. We have with us Dr. S Thipse. I request Kuldeep Patel to introduce our speaker.
Thank you, Professor Yagnesh. Good morning to all. Today we have amongst us Dr. S Thipse, Senior Deputy Director, ARAI, Pune, to deliver a talk on overview of alternative fuel technologies. Dr. S Thipse has done his Master in Thermal Science from Bradley University, USA, and PhD from New Jersey Institute of Technology in the field of alternative fuel combustion. He has research experience of over 22 years in the development of alternative fuel engines and vehicles and has been working at ARAI since 2004. He is currently handling the development of alternative fuel engines in the capacity of Head of Department and Senior Deputy Director at the Powertrain Engineering Laboratory at ARAI. He serves as a member in the Expert Committee on Alternative Fuels of Department of Science and Technology DST and Ministry of New and Renewable Energy MNRE. He also represents India on the Internal Organization for Standardizations in Technical Committee on Gaseous Fuel Standards. He is also a chairman of Bureau of Indian Standards. He is governing board member of SAE India Western Section, life member of Combustion Institute and IST. He is also a member of Board of Studies in Mechanical Engineering at University of Pune. He has published 14 books and 6 patents to his credit. He has numerous publications in national and international conferences and international journals. He has won 4 awards for Best Technical Paper in international conferences. With this introduction, I, Kuldeep Patel, Assistant Professor, Automobile Engineering Department, ADIT, warmly welcomes Dr. S Thipse sir on FDP, Automobile Engineering, Past, Present and Future. Now, I would like to request Dr. S Thipse sir, please enlighten us on the field of alternative fuels and technologies.
Yeah.
Thank you.
First of all, I would like to thank the organizers for having me here. Particularly, I would like to thank Gambawa sir and Patel sir and all others who have asked me to present this. It's always a pleasure to interact with faculty, students and academia in general and sharing the knowledge about a subject which is very close to my heart about alternative fuels. So without any further ado, I will straight away jump into my presentation. So kindly let me know when my screen is visible. Okay. Is it visible now?
Yes, sir.
Yes, sir.
Yeah, okay. So today I'll talk about the alternative fuels from the Indian perspective. I will focus both on the regulatory as well as technological aspects of alternative fuels. So as you know, at present, air pollution is a major matter of concern nationwide, particularly like cities like Delhi. Every winter there is a smog level which is seen, and people always complain regarding the air quality, and again a lot of health related aspects also account for that. And primarily the major cause of that is the burning of the agricultural waste by farmers, and also apart from that there is industrial pollution, there is pollution from automobiles and other construction waste, dust coming from the different areas. So all this contributes to the air pollution. Now, India, unfortunately, has a lot of electricity consumption which comes from coal. And this coal also is one of the major aspects why air pollution is there, because when you burn coal, you release a lot of carbon-based emissions in the atmosphere. So definitely, coal is one cause of concern as far as this is concerned. So this is a snapshot of the air quality index. So AQI is a air quality index which tells you the quality of air. And this is just one particular Monday at 11 a.m. This has been taken from Delhi, and you can see the level is 609. So anything above 100, actually, it is hazardous, and we are as high as 609 in Delhi. So this is a real matter of concern. So that is one major reason why we are looking for clean sources of energy. And if you see the transportation contribution in the environment, so that it is almost the fourth what you call source of pollution. So electricity, that as I mentioned, coal-based generation is the number one polluter, followed by agriculture, followed by manufacturing and construction, and then comes transport. So it is the fourth largest greenhouse gas emitter, but still it has its own share of greenhouse gas. So we have to worry about that pollution. Now, coming to the vehicle scenario in India, if we see, India is a very unique market as far as the world is concerned. We have around 77% two-wheelers. So two-wheelers is a major share of our market, and remaining all is multi-utility vehicles, commercial vehicles, passenger car, three-wheelers, heavy-duty vehicles. So that is just accounting for the remaining 23%. But most of it is two-wheelers, and they are the major what you call segment which contribute to in terms of mobility. So here also another very unique characteristic of India is the fuel price is the highest as compared to purchasing power. What this tells you, that now since the fossil fuel prices are rising continuously, people are spending more money to buy the fuel, and that is affecting their budget. So it is one of the major costs as far as the common person is concerned. So in India, that impact is felt highest as compared to other countries. So this is the data which tells, and as you know that every time we hear that the petrol prices increased, diesel prices increased, and now they are at high levels. So people are worried about the fuel price. So coming to the scenario, what are the options as far as India is concerned? So right now there are three options in India. So our present option, which was already there for so many years, more than 100 years, is fossil fuel. So you have fossil fuel, diesel, you have gasoline, and then you have also the second options, the remaining two options which are now coming up in a big way. One is the alternative fuel, which I'm going to talk about today in a greater depth, and also e-mobility, electric vehicles. So these are the two options which are trying to one can say capture the market, kind of displacing the fossil fuels to ensure good air quality for the country. So these are the three options which we are debating right now. Now, quickly to touch upon the e-mobility, that you know that there is a national electric mobility plan which was unveiled, and the FAME scheme was announced. FAME is a faster adoption of electric vehicles. So that helps to promote development of EVs, technology development, demand creation, pilot projects, charging infrastructure. All that will be part of that electric plan. And in FAME 2, which is the second scheme of that, now incentives also have been given. So that in terms of the size of the battery power plant, the around rupees 10,000 per kilowatt. And for electric buses, there is incentive for introducing more and more electric buses. And then for charging stations, a lot of plans are in place, and almost an incentive for developing charging stations. Some are solar-based charging stations. So this is all what is going on as far as the e-mobility is concerned. Also, the traditional oil companies are also now setting up charging stations. So even Indian Oil and new companies like Ola, they are also setting up charging stations for electric vehicle, which is also a good thing for in terms of the electric vehicle is concerned. So now coming to our main topic for today in terms of alternative fuels. So I identify 5 drivers which are responsible for alternative fuels. So the 5 drivers which are there are as follows. Atmanirbhar Bharat, which is the vision given by our Honorable Prime Minister. that we need to be self-reliant as far as the fuel is concerned. Then we have greenhouse gas mitigation. So in terms of reducing greenhouse gas, because that contributes to global warming. Third important part is we have signed the Paris Climate Agreement. So we have pledged as a country that we will limit the temperature rise to 2 degrees. So this is only possible if you come out of the fossil fuel regime. You have to use clean fuels, you have to use solar, you have to use electric and other sources. Then the next is the local pollution, which I just talked about in my earlier slides. The smog kind of thing where particulate or CO, other small pollutants, HC, NOx, which are all contributing to the worsening air quality in cities. So that is also one matter of concern. And of course, the Indian economy, because we are spending a lot of money buying the fuel from abroad, whereas that money can be spent in the country. Why can't we have our own internal sources? And that money can be better spent within the country rather than spending for buying fuel from outside. So boosting the Indian economy by allowing the local sources so that our farmers get benefited, our overall population gets benefited, overall as a country as a whole gets benefited when we save on the foreign import. And that is why the vision that is given today is to go for alternative fuels is one of the major sources in which we can reduce the dependence on the imported fossil fuel. Now, as far as I am coming from ARAI, one quick slide on ARAI. So what we are doing is we are the official certification agency for vehicle in India. And in that case, we are always associated with the alternative fuel sector. So we have done a lot of regulation formulation. We have done several R&D projects. Then in terms of certification of genset and vehicles, then in terms of training and awareness, IPR generation on alternative fuels, consultancy to the industry for various projects, consultancy to state transport bodies. In fact, I was working very closely with the Gujarat State Road Transport Corporation also. We had visited quite a few workshops in Ahmedabad and other areas. And I'm happy to say that the CNG industry in Gujarat is very forthcoming, and again, a lot of activity going on in that front. So that is one way in which we are associating with different associations for promoting alternate fuels in India. Now, the present government is very supportive for alternative fuels, and there are a lot of regulations which have come out in the last few years. So this is a slide which is a bit cluttered, but there are these are all the notifications which have been issued. By notification, I mean the gazetted norm which comes out as a ministerial publication, and then it is included in the Central Motor Vehicle Rules. So when a notification for a fuel is released, that will allow the certification agencies like ARAI to certify vehicles on that fuel. So in that way, like Bio-CNG, then Biodiesel. Now these GSRs which I'm mentioning, these are available in public domain. They are available on the ministry website or even general internet. And you can take care of that. You can look into that publication, and you can see that it tells you what is the fuel, what is the quality of fuel expected, what is the application for that fuel, which class of vehicles will be recommended for that fuel, what are the emission norms for that fuel. So all that is specified, what are the safety standards to be followed, everything is given in that notification. So like this, you have for biodiesel, you have for CNG was always there, but now for BS6 also it is notified. Then dimethyl ether, which is a synthetic fuel, this is the first synthetic fuel notified in India. Then you have dual fuel technology, ethanol E20. Now ethanol more than 20 also is notified, E85, that is flex fuel vehicle. Then hydrogen is there, hydrogen CNG blend is there, LPG is there, LNG is there, liquefied natural gas, which is also coming in a big way. Then methanol, also all the different derivatives of methanol, M15, M100, M85, all that has been notified in the government regulations. Now, if I want to categorize alternative fuels, because alternative fuels is a very broad area, so I can put alternative fuels in 4 buckets. So 4 buckets are, one is the natural gas based fuels. These are naturally occurring gaseous fuels. So these are gaseous in nature. They are abundantly available in nature. It's only that they are extracted along with the crude oil and they are used as a fuel. So these include your CNG, LPG, LNG. These are all naturally based fuels. Then you have biofuels. So these biofuels are biologically derived. So this is like the origin of that fuel is some living organism, whether it's a plant or an animal or whatever it is. So once upon decomposition, these fuels are generated. So these are biofuels. Then you have hydrogen. So hydrogen by itself is directly not available as in the free form. It is always associated with some other chemical, and you can extract hydrogen from it. So that is the third class of technologies. We say hydrogen technologies, whether it is pure hydrogen, hydrogen Cng blend, fuel cell. So that is one part. And the last bucket is the synthetic fuels. So these are artificial fuels. These are man-made fuels. One can say tailor-made fuels also, because you can design these fuels. You can have designer properties, and they can be produced in the lab and then scaled up. So these are like, for example, DME, GTL. So DME is one such fuel which has been now notified. Many more are coming from big companies like Shell and others. They are researching this kind of thing. So synthetic fuels are coming in a big way. In the future, we will see more and more synthetic fuels coming into the country. So now, if we go further in terms of the vehicles into the front runners. So in all these four categories, what are the front runners? Okay. So in terms of gaseous fuel, of course, CNG is the front runner, LNG to some extent. Then ethanol is the front runner in biofuel. Hydrogen is the front runner in pure hydrogen technologies. And dimethyl ether is a front runner in the synthetic fuel sector. So we will discuss at length all of these technologies one by one. So apart from that, there are, of course, some regulatory rules for alternative fuels, including vehicle type approval rules, which are already there. So ARAI certifies the vehicles. Then there is fuel sale by oil marketing companies, HPCL, BPCL, IOCL. So that rules are there, petroleum rules. Then for the gas station, that is the petrol station also, there are rules. Then cylinder and valve, PESO rules are there. So all these rules are applicable to fuels. So as far as the roadmap for alternative fuel is concerned, we started first with conventional fuels. Then we went on to gaseous fuels. Then we went on to biodiesel and ethanol. Okay. And then from first generation biofuels, we now talked about second generation biofuels. So these are biofuels not generated from food sources. They are using different kinds of technologies. Then we have now introduced recently the synthetic fuels. So this is coming in the next way. And lastly, people are talking about hydrogen as the cleanest form of energy. So this is one of the best source of energy which can be used for vehicles. So we are, I can say, at point number 3 right now. And very soon we will be going to the point 4, 5, 6 in the near future. Now, SIAM, that is the Society of Indian Automotive Manufacturers, they came out with a very nice white paper on alternative fuels. So what they did is they studied the Indian market, they studied the different alternative fuels, and they gave a clear roadmap to what kind of solutions would benefit India. So it was a very well documented study. This is available on the internet if anybody is interested. So those studies mentions about what are the different technologies available, what is the scenario as far as the Indian vehicle industry is concerned, and what is the recommended fuel segment wise. So what they have done is they have made a whole table according to the class of vehicle, two-wheeler, car, three-wheeler, bus, truck, LCV, and what are the different fuel options available, what is feasible, what is available, what is not there. So all that they have very nicely documented, and they have almost covered almost all of the fuels. And they are this document is one guiding document from the SIAM, that is the auto industry for the government. Then new applications are coming. So this is something very interesting, that apart from your traditional automotive application, there are many other sectors which were traditionally fossil fuel based are now going on to the new alternate fuels. For example, you have tractors being developed on CNG now. You have biofuel for aircraft. Railways is using CNG and other modes of transport. They are going electric also in a big way to kind of come out of diesel consumption. Then marine also, they are talking about hydrogen. They are talking about LNG, many other applications. Then off-highway, as we call it, that is those applications which don't come on the road, like excavator, mining equipment, machinery, construction equipment vehicle. So those things are also being talked about on alternate fuels. Then generator, power generation is one big area. So CNG was used for that, but many other fuels are also now being discussed, whether you can use hydrogen fuel cell instead of generator. So all these things are the new application for alternative fuels being discussed. And there is a big debate which is going on whether the IC engine itself will survive in the future. So this question keeps getting asked at all forums, whether IC engine will survive. So the answer is the engine won't die so easy. It has been there for a long time. It will continue to remain. Of course, EV will eat away its market slowly, but it is not going to totally disappear. Again, this is a study by Arthur Little. You can look it up on the internet. The entire report is available, which tells you why the engine is still having a fighting chance. Because what it says is, in terms of cost, battery electric vehicle is more expensive. And in terms of the warming potential and secondary environmental impact, BEV is there. But IC engine still is also having its own chance, because it is also getting more and more efficient day by day. So it is not like you should rule out the IC engine. IC engine will also survive. Many applications which I mentioned, the off-highway especially, they still depend on the engine only. So there the electric mobility will not reach so easily. Heavy-duty applications, two-wheeler, three-wheeler, definitely electric vehicles will be more. But in terms of the heavy-duty application, off-highway application, marine application, many other applications, there only the engine will still survive. And that is what is the hope for the future. Now coming to one by one the different categories of vehicles. Let us first start with the gaseous fuel category. So here I'll talk about the different technologies. And first I'll talk about CNG, because that is the best known fuel to all of us. This is the leading alternate fuel as far as the gaseous fuel is concerned. So it has been notified right from BS2 onwards. Latest notification is for Bharat Stage 6, which tells about the gas quality. Then the Indian standards for CNG are also available. Then as far as cylinder is concerned, the gas cylinder rules are notified by the explosives department known as PESO. So rules are in place. Again, advantages is it's a very low carbon fuel. It is methane only. It has low particulate. It is renewable. If you generate it from bio-CNG route, it is a renewable fuel. It is very much cost effective, although the cost of CNG is also increasing day by day. But still, I'll say as compared to diesel and petrol, still that delta is available. Some cost is lower, so that benefit is given to the customer. So that's why you see now there's a lot of interest in CNG applications. Many OEMs are developing CNG vehicles now, because what is happening is the diesel vehicles are being phased out, and then slowly the people are shifting to CNG because they don't want to directly jump to electric. So you are seeing a surge in CNG vehicles. And infrastructure wise also, CNG is getting built all over India. In Gujarat already very good infrastructure is available. Other parts of the country also, especially eastern region, Kolkata and other places, through the ports, through LNG, that is regasification of LNG, lot of activities happening, and the infrastructure is getting built over a period of time. So around 11,000 kilometer pipeline is there, and 10,000 CNG stations have been announced by 2025, and more than 15 million vehicles will be expected by the 2025. Now coming to the applicability of CNG technology, you see that CNG technology is applicable currently for cars, SUVs, for three-wheelers and buses. We are not using CNG in two-wheelers mostly because of the space constraints, but mostly the three-wheelers are being used on CNG, cars and the buses for public transportation. Like in Delhi, a lot of entire bus fleet is on CNG. So it's a good thing. Many other cities are also following suit, and it is a clean fuel, as I mentioned to you. And as an urban transport fuel, CNG is very good because it is a clean and safe mode of transport. CNG is a very safe fuel. It burns very slow with a flame, low flame speed, and auto ignition and all is high. So there is no issue with respect to fires and everything. But in terms of meeting the norms, you still have to use a three-way catalytic converter. And there are some concerns regarding nanoparticular matter, but those are less as compared to the diesel and petrol. CNG is definitely cleaner. Now, in terms of classification, you can classify it as a dedicated fuel, a biofuel, or a dual fuel. So all three options are available for CNG. Dedicated means it's a pure CNG vehicle. Biofuel meaning CNG and petrol vehicle, but using only one at a time, either CNG or petrol. Earlier times, these vehicles were there. Now they are no longer there because CNG is available in many places. So the biofuel vehicles are being phased out. These are the older vehicles. And dual fuel is something new, which are like a mixture of diesel and gas together to clean the diesel combustion, to improve the combustion, reduce emissions. Diesel plus gas dual fuel technologies are there, which are being introduced in India. So this is the classification of 3 types of CNG vehicles. Now, coming to the developments, we have developed in ARAI many CNG engines for BS6, and many such technologies have already been done. And these kind of engine programs have been running in ARAI for a very long time. Now, coming to the next fuel is the Bio-CNG. So Bio-CNG is the derivative of biogas. So you know that any waste which can be fermented will generate biomethane. So it is kind of a waste program. And from that waste, the biogas is produced. That biogas contains hydrogen sulfide, it contains moisture and carbon dioxide. There are 3 impurities which have to be removed. And once you remove those impurities, it becomes just like CNG. So it becomes a bio-CNG of sorts. And then it can be used as automotive fuel. So without purification, biogas should not be used as a fuel because it will lead to corrosion problems. But with purification, you can use bio-CNG as a vehicular fuel. Rules are already in place. The notification for that is already there in Right Way 2017. And also the safety standards for bio-CNG and the BIS standards are also in place. So Bio-CNG is a very good fuel for rural application, particularly tractors, or you can say rural genset, or for pump set, agricultural pump set. So you can have waste generated in the farm, agricultural waste, you convert that to biogas and use it there itself. So this kind of technology is used in Brazil, Argentina, many such developing countries. So India should also take full advantage of this kind of technology and generate fuel locally in the rural areas. So as CNG is a fuel for rural urban areas, Bio-CNG is a fuel for rural areas. So in terms of third class of technology is the LNG. Now this is a fuel for highways. So this is best for trucks and buses which run on the highways. Advantage of liquefying natural gas is you can get a more mileage, more range, because a CNG vehicle can run up to 250, 300 kilometers at one filling. But this vehicle can run up to 1200 kilometers in one filling. So this is ideal for those trucks and buses which go on the highways for long distances, which run all throughout India. So that is the vision of the government, that they want to bring LNG on the highways. So they want to develop LNG corridors. And this, they have already notified this, all the safety standards, everything is already in place. So, and at present, LNG technology is best suited for buses, trucks, and LCVs. So this, as I mentioned to you, is for the heavy duty vehicles, which can help in terms of increasing range. Because here CNG is not good, because CNG cannot give you that mileage in one fill. Secondly, in terms of there are some operational challenges are there. So here LNG is the best technology because it is very compact. It is just like a liquid fuel and it can work very well. And in India, there is Petronet, which is the government company, which is promoting LNG. So along the ports, as you know that the LNG is coming along the ports and then it is supplied hinterland also. And along the highways, an entire network is being developed. So this is the LNG corridors. So the first terminal was in Dahej and the second one was in Kochi. Now the third one is coming in Maharashtra and Dabhol. And then there are fourth one planned in Ennore, Tamil Nadu, and one in Kakinada in Andhra Pradesh. And then we have Haldia, which is in Bengal. So all these ports and all the connectivity, it will give very good availability of fuel along the coastal regions. So on the highways and the coastal regions, LNG is the best choice as a fuel is concerned. Then in terms of technology on the vehicle also, there are cryogenic tanks are required. So all this is being developed in India, and now local suppliers are also available for this particular technology. So possibilities, definitely LNG can be used as a highway fuel. New infrastructure is being developed, and definitely there is going to be a good possibility for the Indian market. So apart from that, as I mentioned, dual fuel is another technology which is very important from Indian perspective. So diesel CNG mix dual fuel. Now why this has been promoted, I'll explain. The older vehicles of diesel engines, they are still in the field, and they are becoming kind of a burden because of the environmental impact. But if you substitute some part of diesel with natural gas, so what happens in the ordinary diesel engine, your air comes in, it is compressed, then the diesel is injected and it auto ignites. So in this engine, air plus gas comes in. So the CNG is introduced into the manifold. So air plus gas comes in, gets compressed, and then the diesel ignites the air plus gas. So what happens is, because gas is inside the combustion, it becomes cleaner. So the particulate matter, smoke, everything reduces. Secondly, engine can run on diesel anytime. If gas is not available, it can run on diesel. No need of any major modification on the engine. Simply you have to adapt the CNG fuel system onto the engine. So this is very good as far as India is concerned. This technology can be used for automotive, genset, off-highway. So lot of potential for this particular thing. And we have developed in ARAI many applications on this. So we have done heavy duty, we have done SUV, we have done tractors. So in fact, 2 of my patents are on this dual fuel technology, because we have applied for patents, and this is the first time to my knowledge that we have done in India. And now the dual fuel norms are also there, and even now certification of dual fuel vehicles is possible. So one such certification of dual fuel vehicle for off-highway was done in Delhi recently, and that vehicle is successfully introduced. So as I mentioned, CEVs is one very good application, and many other countries like Thailand, New Zealand, Australia are using this kind of technology as far as the dual fuel is concerned. Now coming to the second class of vehicles, which is the biofuel. So biofuel, in this, the 3 major parties or 3 major fuels is ethanol, biodiesel, methanol. So I will talk one by one on all of these 3 fuel. Now biofuel, the name itself tells you that it is generated from some biological source. So some kind of animal or plant crop is there. So oil crop is there, for example. Then the oil crop will yield seeds. Those seeds, you can extract oil out of it. And then after refining, you do the transesterification, you get biodiesel. Or if you do other processes, some alcohol. So in terms of some fermentation processes followed, you get alcohols also. So alcohol, biodiesel, whichever is the biofuel extract. From that, you get valuable byproducts like glycerol. And then that fuel is used in the vehicles. And when you use in the vehicles, you are again generating CO2. But mind you, the plant, when it was growing, it was absorbing CO2 from the atmosphere during photosynthesis. So actually what the plant is doing, it is taking CO2 out of atmosphere, and from the fuel, the CO2 is generated back in the atmosphere. So actually it is not adding to the CO2. It is simply recycling the CO2. So that is called carbon neutral concept. So all the biofuels do not add to CO2 emissions, because while growing up, they are already reducing the CO2, and they are simply adding that CO2 back to the atmosphere. So it is a zero balance kind of thing. So that is the biggest advantage. Hence, biofuels is the way in which you can achieve very low carbon emissions. So biofuels is one way in which we can fulfill our requirement for the Paris Climate Agreement. So apart from being carbon neutral, they have low emission, they are renewable, the low shelf life, and those kind of some issues are there, but we are trying to solve those issues through additives. Now in India, the biofuel policy has been released. Now the 20% blending is getting preponed to 2025. So this is something which is there. Now E20 we have been talking about. E10 is already notified. Already E10 is followed in many parts of the country. Remaining parts will be E10 by 2022. But 2025, we will go with the E20. Okay. And apart from sugarcane, government has also permitted damaged food grains, then surplus food grains, starch containing materials. There also can be used to generate ethanol. So what this does is, not only it utilizes waste food grains, which human consumption is not possible. Apart from that, other sources which are otherwise not getting enough market rate, those are also now going to get a market because of this policy. So that is a very good initiative from the government. And there are some issues in terms of methanol also being talked. So whether we go full the ethanol route or methanol route, so a lot of discussions are still going on in that way. So the launch of E20 fuel by the Honorable Prime Minister, and this is the graph on the right side, how the ethanol blending is improving. So in terms of right now, we are somewhere around 8.5%. and from 8.5% next year we hope to achieve 10%, and then 12, 15 the intermediate steps are also notified, and now 20% is what the achievement target is by 2025. And then we are going to kind of continue this arrangement for a few years, and then later on we are also going to go parallelly with the flex fuel ethanol development. So that is also going to be planned. So this is the roadmap which has been released by Niti Aayog about the availability of ethanol. This is available on the internet. You can look into this roadmap. It tells you all about what are the measures which government is taking, what kind of benefits they are going to give for ethanol generation. And they are also continuously improving the ethanol price. So right now, earlier when I remember, it started with 27 rupees a liter, then it reached 45, 46 rupees a liter, and now it is highest around 60 to 70 rupees a liter. So that is what is the benefit given to the ethanol producers. Now the government is also planning to introduce the flex fuel vehicles. So flex fuel is a very high percentage ethanol vehicle, E85 or higher. So with this, you can get flex fuel vehicles in India, and that will help in terms of increasing the ethanol consumption. So today itself, I heard that within 6 months, this policy is going to be announced for flex fuels. So next is in terms of standard and regulations. Definitely standards and regulations are already in place for E20, E85, E100, everything is in place. Safety standards also been notified, all that is already in place. Now there is another technology very unique for India. This was developed in Sweden by the Swedish manufacturers, Scania and other things. So here, this is the use of ethanol in diesel engine. So you can use up to 95% ethanol with additives in a diesel engine, and this is best suited for buses, trucks and LCVs. So the basic operation of this is a compression ignition engine with ethanol blend, but the efficiency is as high as up to 45. So that is equivalent to the diesel. So this is the technology, and this uses very high compression ratio engine with additives. So with that, you can use ethanol in a diesel engine directly with ignition improvers. So such kind of buses have been developed by Scania, and a few of these vehicles are already running in Nagpur. So these are the Scania based buses, which are pure ethanol buses running there in the local corporation. So with this, I come to the end of the ethanol work. Now I come to the methanol as the next fuel. So as you know that in India, there is a lot of high ash coal which is available, which is not suitable for power generation. So the idea was to convert that high ash coal to methanol. Now why methanol? Because methanol is also another fuel which is of interest, and it has many applications. I will just show what is happening. So this also has been notified by the government, and the application in terms of using methanol for multiple vehicle technologies is there. So here, methanol can also be used similar to what ethanol is being used for many other applications. So methanol is a very valuable byproduct. Not only you can generate fuels from methanol, you can also generate chemicals from methanol. And you can generate methanol from various sources. For example, you can take natural gas, you can take coal, which is the current practice. But biggest advantage is you can use biomass, that is waste. Then you can use atmospheric carbon dioxide, which is a cause of concern. So all this can be taken up, captured, and now projects are on to convert all of this to syngas to methanol. And once you generate methanol, from methanol, you can generate ethanol, you can generate DME, you can generate gasoline. So many things are possible. And also chemicals. So there are some valuable chemicals which are used in multiple industries, like olefin is there, formaldehyde, acetic acid. So methanol economy as such is being promoted. So Niti Aayog is promoting this in a very big way, the methanol economy in India. So at ARAI, we have done work on the 15% blend of methanol with gasoline, M15, and we used it on a gasoline vehicle, and that report was submitted to the Niti Aayog that it is feasible to use M15 in the vehicles. So coming next is the biodiesel. So biodiesel is another fuel. It's a esterified form of vegetable oil. So basically, you know that vegetable oil is a oil which is extracted from vegetable seeds, and once you do the transesterification reaction, you can get biodiesel, and this biodiesel is a wonderful fuel for the diesel engine, because it is definitely going to reduce emissions. But there are some issues with biodiesel also in terms of clogging, cylinder deposits, then oxidation stability. But there are many countries which are using this technology. In India, B7 fuel is notified for Euro 6 diesel, that is Bharat Stage 6 diesel, and then B20 is allowed and B100 is allowed. There is a lot of talk of B30 also now being discussed. Many manufacturers are asking for standards for B30 also. So biodiesel technology is ideal for CI engines which are used in buses, trucks and LCVs. You don't need to make any changes in the engine, simply switch from diesel to biodiesel, and it has excellent lubrication properties and lot of benefits are there. So with the biofuel, biodiesel also will take up in a big way in the future. But right now there are some hurdles for biodiesel production. So we are still hoping that some of the issues can be solved, especially with respect to availability of oil seed. Then the oil seed varies from region to region. Quality of biofuel produced, there are a lot of issues which are being sorted out. Now coming to the third basket of technologies, which is the hydrogen now. So I've talked about hydrogen, hydrogen CNG and fuel cell. So these are the three technologies what we are discussing in this area. Now, first of all, when you say hydrogen as a fuel, it is termed as an energy carrier, because what happens is hydrogen is always associated with some other molecule, whether it's oxygen, whether it is carbon, whether it is nitrogen. So in oxygen, it is water, H2O. If it is nitrogen, it is ammonia. If it is carbon, it is hydrocarbon. So it is, you have to extract the hydrogen from the molecule, and then you have to burn it to get the energy. So you spend energy extracting and then you burn the energy. So it becomes like a carrier. So that's why it is called the energy carrier. Again, it is zero carbon fuel, absolutely no question of any carbon based emissions from this. Highly efficient, it has a very high flame speed, it is an excellent fuel, and there are some challenges in terms of its storage and other things, but more or less a lot of research is going on. Now in recent times, you must have seen a lot of people are talking about hydrogen IC engine. There's a huge interest now suddenly developed on hydrogen IC engine, because it is one of the cleanest forms to meet all the future emission norms. Any emission norms can be met with hydrogen. So there is no question about it. Almost like a zero emission fuel. Of course, it's not totally zero. H2O is there as the emission, but which is not really harmful. So definitely there is not going to be much of a concern. Then you can use it in engine, you can use in fuel cell, many other applications are there. So hydrogen is a very good fuel for the future. So there are a lot of production methods for hydrogen. So one is gray hydrogen, blue hydrogen, and green hydrogen. These are the three methods. So what is gray hydrogen? Gray hydrogen means you generate hydrogen from natural gas, that is methane, but you release the carbon dioxide in the atmosphere. Means you don't control the emission from the process. So CO2 is emitted in the atmosphere during hydrogen production. Blue hydrogen, this is what India is looking for in the medium term. That is, you use natural gas, but you capture the CO2. Don't allow it to go outside the atmosphere. So that carbon capture methods are being used. So this is in the short term measure for India, blue hydrogen. And when we say green hydrogen, means you use total renewable energy for generating hydrogen. There is no carbon at all anywhere in the picture. So you use solar energy, you use wind energy, tidal energy, whatever you want to use. So that energy can be used to split the water by electrolysis, and then you can definitely store it. So there is no environmental impact for this kind of hydrogen. This is the best possible hydrogen, but unfortunately the cost is the highest for this particular hydrogen. So this is the hydrogen which we will be using in the future. So for the intermediate step, India is focusing on blue hydrogen, and in the long term we are focusing on green hydrogen. Now India has recently unveiled the National Hydrogen Mission. So this is what has been unveiled, and the whole idea is to generate volume and infrastructure for hydrogen, have demonstration projects. Already some fuel cell vehicle buses have been developed, which have been going to be demonstrated in Pragati Maidan, in Delhi, even in the Statue of Unity. There will be hydrogen fuel cell buses which will be running, and then there is the power corridor which is planned. Hydrogen from green power sources, and then hydrogen fuel cell mission is there. Under the PLI scheme, hydrogen fuel cell technologies have been promoted. So a lot of activities happening on the hydrogen front. As I mentioned already, hydrogen engine is being developed. We at ARAI also are now very shortly initiating the hydrogen engine program. So a lot of activities are going on. So as far as rules regulation is concerned, already hydrogen is notified as a fuel. All the standards for cylinder fuel are already in place. National standard, international standards, everything is available. And so this technology, as I mentioned to you, is ideally is a spark ignited engine, which can be used in either cars, three-wheelers, buses. So everything is possible with this. Only issue is it's the extremely high flame speed. It's a bit dangerous to handle. Just like that, you need to have a lot of safety features, because hydrogen is not so simple to handle. It can cause catastrophic accidents. So one has to be very careful regarding safety of hydrogen. So unlike CNG, hydrogen is very aggressive as a fuel. So in new engines, you can use it either as a neat, that is 100% hydrogen engine, or you can use it as a blend with petrol. Some people have tried that also. Then you can use it as a CNG mixture, hydrogen CNG, HCNG as we call it, or you can use it as a dual fuel with diesel hydrogen. So all these multiple technologies are available. Right now, we are mostly looking at pure hydrogen and hydrogen CNG. So as I mentioned, technical issues are there. A lot of research is required in terms of the flammability limits or the flame speed. Then again, ignition energy is low. There is a phenomenon called as misfire, backfire. So backfire is also there. Backfire means the flame, instead of traveling from engine to exhaust, travels from engine back to cylinder. So it is very dangerous. I mean, it's the fuel cylinder I'm talking about. So there you have to have spark plug arresters. You have to have valves to ensure that the flame is trapped, and that kind of things are required. Then there is a metal embrittlement tendency. So you cannot use steel cylinders for storing hydrogen. You have to use composite cylinder. Composite means more than one material. So you have to use a plastic liner or other kinds of liners. So fiber wrap plastic liner cylinders type 3, type 4 are used for storing hydrogen. And again, low density requires higher flow rates. So these are some of the major issues with hydrogen. Again, roadmap which I mentioned to you, that government is very keen on using hydrogen for the future. Then coming to hydrogen CNG blend. Now this is the mix of hydrogen and CNG together. This is also notified last year. And the benefit of this is for as a transition technology for buses especially. So in Delhi, there is a program which is going on. So what is the advantage? That you use CNG, which is already well developed, and you use hydrogen, which is the fuel of the future. So you have a blend of both fuels, and you try to get best of both worlds. That is, you get the advantage of hydrogen efficiency and safety of CNG. So when you have HCNG, the emissions are even lower than the CNG emissions. So that is the biggest advantage. And at the same time, you get better combustion efficiency. So you can get emission advantage. A lot of work has been done in India in this. ARAI also work has been done. IOC has done work. So right now, what I was saying is there's this in terms of hydrogen CNG vis-a-vis CNG. There's CO reduction, NMHC reduction, NOx reduction is there, CO2 reduction. One of the complaints against CNG was that NOx is not reducing, but in this technology, NOx also will reduce. So definitely, this is one very good technology for India. So right now, there is a pilot project in Delhi which is being done on HCNG under the aegis of Supreme Court. So as I mentioned to you that ARAI also did a lot of work on this, BS4, BS6 applications on hydrogen CNG blends. Many of our publications are available in SAE domain. You can look it up. We developed engine for different blends of hydrogen CNG 5, 10, 15, 18 and 20. Around 20% blend is the best. So for India, we have notified 18%. And many such more activities are there. So this is the project I was talking about in Delhi. There is almost 40 buses are running on hydrogen CNG blend, and their MNRE, MOPNG and MORTH have collaborated to run this vehicle program. Then coming to the fuel cell. Now fuel cell is nothing but something equivalent to a gas battery. So in a battery, you have chemical energy of the battery is converted to electrical energy, and that current is used to drive the motor which drives the vehicle. Here, you have hydrogen coming in ionic form, rather a gaseous form, and you have oxygen from the air. And both are generating ions. So they become electrolyzed, they become ions, and then they are attracted towards opposite electrodes. And with that, the current is produced. So it is something like a gas battery, you can call it. So you get three things out of the fuel cell. One, You get current, you get water, because hydrogen and oxygen combine to form water, and lastly you get heat. So there are three things which are coming out of a fuel cell. All three are very important. So actually fuel cell came from space application, because in space there was no space to keep the heavy batteries. So they invented the fuel cell, because the electricity from the fuel cell used to drive the equipment, the heat was used to heat the cabin, and again the water which is coming out of the fuel cell was astronauts were drinking that water. So that was the whole what you call initiative behind this. Now this technology has come to the automotive domain. So Japan was the first country which went into this. Lot of development on this. So if we see in India now, a lot of fuel cell activity is being done. Buses have been developed on the fuel cell. So here, if you can compartmentalize the whole hydrogen fuel cell vehicle, it is having a fueling receptacle, then you have a storage container, then a regulator, then the fuel cell stack is there, because one fuel cell is not enough to drive the whole vehicle. So you need a multiple fuel cells. So that is called a stack. That is all fuel cell in series. And then you have the electrical part of the vehicle, because the fuel cell is going to produce electricity which is going to drive the vehicle. So the electric vehicle is in form of battery, ultra capacitor, motor. So this is just similar to an electric vehicle, but the energy which is coming from the fuel cell part. So that is something which is kind of the process which is being followed here. Now in India we have the AIS 157 standard which is already available. And this particular standard is a safety standard for fuel cells. And here we are talking about the general requirements, then the safety requirements, what are the safety checklists which are there. All that is being discussed in this standard. And this standard has been developed only last year, and this will be used for certification of fuel cell vehicles. Very exhaustive document. This is available on ARAI website. If anybody wants to see this document, it is available free of cost. Then this particular standard, there are multiple domains which have been covered. So what should be the standard used for nozzle? What is the standard for storage? Then what is for the component, for the fuel cell system? So reference of international standards have been given. And then for the electric part, what are the standards, the AIS standards, which are already notified, similar to electric vehicle. So that's as far as the hydrogen and hydrogen fuel cell is concerned. Now coming to the last basket is the synthetic fuel. So this is something which is very new, and that not much information is available on this, but I'll try to attempt and giving as much information as possible. So DME, as I mentioned to you, the first synthetic fuel to be used in India. It can be produced from natural gas, it can be produced from coal, it can be produced from biomass, it can be produced indirectly from methanol via dehydration. It's a very good diesel alternative. It can be used as a diesel. It is gas at atmospheric conditions, similar to LPG in storage, and very low in emissions. So we'll discuss how it is beneficial to India. Why DME? So as I said, the rule notifications, everything is there. DME is also notified as a fuel, and the Indian standard already for the fuel is already present. Now, basically, this is recommended for diesel applications. So vehicle bigger applications, it is notified. So here worldwide, if you see, there are countries like Scania, Volvo, then Sweden, which is one country where agencies like Scania, Volvo, they have developed vehicles running on DME. So there are trucks which are running on DME, engines have been developed, a lot of activities going on. And basic advantage is the emissions of DME are far lower than diesel. So it's a compression ignition engine running with DME. So that is the only difference. So instead of the diesel system, you have to adapt the DME system. Of course, it's a pressurized system because DME is gas at room temperature. So you have to pressurize it and then inject it into the vehicle. Now, the cetane number and auto ignition characteristic of DME is better than diesel actually. So it is very easy to use it as a CI engine, that is a compression ignition fuel. And some few minor modifications are required, but definitely you can use it very easily. And the LPG storage tanks can be used to store DME because their pressure is similar, around 8 to 10 bar, roughly average 9 bar. So there are some challenges also in terms of lower calorific value, low viscosity, but these can be worked out through R&D, and a lot of activities going on in this particular area. So it is a clean fuel, as I mentioned to you. If you see emission wise, it is even meeting all the regulatory requirements for BS6 also. And a DME engine fitted with EGR is having better characteristics than CNG and has excellent fuel ratio, and it can give very good mileage and is very attractive. Again, cost of DME will be definitely lower than diesel. It will be similar to CNG, around 60 to 70 rupees a liter or kg, as you say it, for CNG. And then as compared to the diesel, it will be definitely much cleaner and also cheaper. So this is the one reason why DME is being looked upon. Also, DME can be blended with LPG. So as you know, there is a LPG shortage in India, so we are importing LPG for domestic application. So there DME can be blended with LPG and also can be used for domestic cooking application. So coming next part is the research and development. So now you know that any fuel which you want to bring in, whether it's a gaseous fuel, whether it's a biofuel, whether it's a synthetic fuel, whether it's a hydrogen-based fuel, all these require development. So R&D is very critical. Now R&D will talk about material compatibility, it will talk about fuel characterization, it will talk about engine trials, the durability trials, emission studies, then vehicle emission studies, then you have vehicle trials on the road. So in terms of characterization on the road, what is the feedback of that fuel, what are the pros, cons, and then based on that you have to frame policies for that fuel. So all of that R&D is very important, and that is where agencies like ARAI are very important, because they continuously are developing programs for evaluating new fuels, making standards, certifying them. So this is very important as far as India is concerned. So as far as I'm concerned, that's it from my side. So now I will be very happy to answer questions on any of the topic which we have raised. So that's all as far as I'm concerned. Now over back to organizers. I'll just stop sharing. Yeah.
Thank you very much, sir. There is a one question from participant side, which is available in chat box.
Yeah. Okay, let me just check it. Because it is a problem. Okay. So basically, I'll tell you what happens is, as far as I'll talk about SVO first, straight vegetable oil. As you know, straight vegetable oil is more viscous, so it is difficult to flow through the lines. So you need to have some heating to make it flow. Okay. As far as DME, the problem is other way. Because of the low viscosity, actually what happens is the FIE equipment, the injector, that all is calibrated for a certain throughput. Throughput is the flow rate. So when you have a lower viscosity fluid, basically it may so happen that it will have a more flow than what is intended, which in terms affect the fuel efficiency, rather fuel consumption in a negative way, so that you will spend more fuel than what is required for actual combustion. So that is the problem. So that calibration of the flow equipment is done as per the viscosity of the fuel. Now, originally the vehicle is designed for diesel, so the viscosity of diesel is taken into consideration while designing the pump and fuel pump and all that lines. So if you have a low viscosity fuel, also is an issue. If you have a high viscosity fuel, also is an issue, because it will affect the flow rate, and then it will affect the fuel consumption, and in turn affect the BSFC, that is brake specific fuel consumption. That is the problem. So you have to recalibrate it. It is not such a big problem. It is just that you have to recalibrate the flow rates, you have to adjust the pump settings, you have to make certain adjustments, and then the problem can be solved. But that you have to take care of it. Yeah. I think then another question, anything about plasto oil which can be utilized in petrol engines? I think you are mentioning about plastic to oil. Is that what is being referred? Okay. So waste plastic pyrolysis oil is also another area which is being discussed. So you have a lot of plastics lying around, and that can be converted to fuel. So plastics I can classify in three types. One is polystyrene based, polypropylene based, and there is the polyvinyl chloride, PVC. So PVC, PP, and polystyrene. So polystyrene is basically packaging material. Polypropylene is also there. PVC is a hard material for pipes and all. So each class of plastic has its own plus and minus. Now, problem with plastic changeover is what temperature to use for changeover. So for pyrolysis, basically it is done to convert that plastic material into the hydrocarbon. Basically, plastic is also hydrocarbon. It's a polymer. Polymer means a long chain hydrocarbon. So you have to break the chain and then form the fuel from it. Okay, at a particular temperature in absence of oxygen. So those technologies are being developed, but the issue is there are certain materials in plastic which are a concern, like chlorine is there. So that chlorine will form some undesirable emission when it goes into the combustion. So you have to clean that plastic, you have to shred that plastic, you have to make sure that it comes to a certain size, and then it can be used. So it can be directly used. And again, it is not advisable to mix all the plastic together and use it just like that. So you have to classify the plastic actually. So these are questions. Again, there have been efforts which have been done in India for plastic conversion. Some oils have been developed, but what is the complaint which I have seen is that they become corrosive. So if you don't take care of the chlorine and other things which I mentioned to you, it forms acids, so it will be corrosive. So it is a good technology, but it requires more research. In fact, IIP did some lot of work on this, and they have made up some certain formulations. So if this kind of work can be done, it's a very good source because we have a lot of waste plastic lying around, and that can be used for fuel. But there are some concerns which need to be addressed through research. Now, you have mentioned about flex fuel. Can you throw some more light on flex fuel? So you see, flex fuel is the technology which is ethanol based. So we common term for flex fuel is E85. Okay, what is E85? So basically, flex fuel is a vehicle which has two tanks. One is a gasoline and one is a ethanol. So there, what happens is it is not a pre-blended fuel. Means there is no fixed formula. It is a variation, flexible fuel. So what happens is, as per speed and load, there is a ethanol sensor in the tank. So what it will do, it will sense the quantity of ethanol in the tank. And according to the speed load, there is a logic built in. For this speed, this load, this much should be the blending of ethanol. So the ECU, the controller, will take this much ethanol, it will take this much gasoline and then inject. So that is the intelligent controller is required, a sensor is required. And then that vehicle, according to speed load, will vary the fueling of the blend. That is called flex fuel. So there is no one formula. You can use any combination. And that depends. Suppose tomorrow you are running out of ethanol, so you can run on the gasoline also. But at the other way, if you have 100% ethanol, you can run on the 100% ethanol also. So there are different combinations which are possible. But to strictly speaking, the range is 53 to 85 is what they classify as flex fuel. Above 85, they say it's a pure ethanol vehicle, 100% ethanol. So what we are looking in India is, you know, that the ethanol supply is there is vagaries in the sense there is a lot of variation. So suppose today there is so we should have a vehicle, we should run on 40% also, it should run on 50% also, it should run on 70%, 80%. आज का जो ethanol stock है, whatever is the ethanol stock available today, it should run on it. That is what is envisaged in the flex fuel technology. So it is a vehicle which can tolerate any blend of ethanol over a certain range, and it can be used to run the vehicle. So that is a way of increasing the ethanol percentage in the fuel structure. So that is why flex fuel are being promoted. With flex fuel, you can run on the other fuel also, in gasoline also or ethanol also, and that flexibility is there. So that is the advantage. बाकी का CNG engine, you need CNG. Without that, you cannot run it. इसमें ऐसा नहीं है. Ethanol थोड़ा आगे पीछे हुआ तो भी you can run that vehicle. So that is the biggest advantage. Yeah. Then you said about electric vehicles. Can you please explain what time conventional fuel IC engine can be used in India? See, as I mentioned to you earlier in this thing, that electric is one option. It is not the only option. Okay, electric is good up to a certain level in certain sectors. I am aware that a lot of talk is there that you go for 100% electrification, but 100% electrification is not possible at this present moment because we don't have the infrastructure for charging. We don't have that much battery We don't have a single manufacturer. We don't have the plants. We don't have the lithium sources. And we are even facing shortage of semiconductor chips. So much problems are there. So in absence of that, it will not be possible to jump 100% to electric. So it will take time. Any technology which comes in now, CNG came in almost 20 years. It is still struggling to make a foothold. It has reached certain cities, but still even now it is not fully available. So this electric also will take time. I'm not saying it will not come. It will come, but it will take time. So to my knowledge, at least 20-30 years is a full frame where the entire, I can say, a big chunk of mobility will go on electric. Right now, we are nowhere there as far as the scenario is concerned in terms of what you call infrastructure. You see, charging infrastructure is a major requirement. Suppose tomorrow, let us say, all the vehicles go on electric. Where will they charge? Yeah, on the highways there is no infrastructure. In the cities also it is limited. You have to build it. You have to build all that thing. You have to plan for it. Then you can go into the full-fledged electric mode. Smaller applications, fine. Two-wheelers and all, they can very well go 100% electric. No issue. Larger applications, buses, trucks, you have to look for that. City buses may go on electric, but what about rural areas? So those things have to be looked into. So that, to me, it will take time. It is not going to be sudden. Yeah. Any other question? I think that's all from the question side. Yeah. Any other question is there?
Thank you so much, sir. Having the good answer. Now I request Dr. Sanjay Patel for a vote of thanks to our today's speaker, Dr. S Thipse.
Thank you very much, Yagnesh. It's our privilege to have you as an expert speaker, sir, in our FDP. It's like always we have a feeling that we want to hear you again and again. I think this is true for every participant also, because I don't think any other person in India could be the best person other than you as far as alternate fuel is concerned. That's what we think. So thank you very much, sir, for enlightening us with different sources of alternate fuels and other things. So on behalf of Automobile Engineering Department, on behalf of entire committee and participants, I would like to thank you, and in future also we will be having a good interaction with you. Thank you very much, sir. Thank you.
Yeah. Thank you. It's my pleasure always to interact, and I'll come again and again if you invite. No problem.
Thank you, sir. Thank you.
Yeah. Thank you.
Over to you, Yagnesh.
Thank you so much, sir.